All right, hello there, boys and girls. We are continuing our journey. We are learning, actually, I'm learning, and you are watching if you are interested in this channel. I'm learning C. I'm following a book by Daniel Holden. It's called Build Your Own Lisp. It's a great book. I think mostly how I'm gonna construct the channel is I'm learning. If you want to watch me, if you want to suffer watching me, then you can join. But I will be learning. I will most probably use some textbooks, either from the uni or I don't know some good books that I find about online, and I will go through them. So there are some couple of changes. I downloaded this open source app on Ubuntu. It's called Joplin. It's gonna help me structure my videos better for now. So I mean it says here the 9th of October, but I don't think I'm gonna make it through all of these videos. I'm gonna do some, but I'm hoping to do these sub chapters from the book. Okay. So what was the last thing? Yeah, this was the last thing. I'm missing this method. But before I even do this, let me just check something. Lambda function. Can I save this? Okay, so it's saved automatically. Okay, lambda functions. So let's just go through lambda functions again. First of all, what are lambda functions? Where's my good old friend ChatGPT? What are lambda functions? Okay, so those are small unnamed functions defined with the lambda keyword in programming languages like Python. They are typically used for short, simple operations and are defined in a single line. Lambda functions can take any number of arguments, but can only have one expression. The result of that expression is automatically returned. Okay. Why don't I write this? So yeah, I'm gonna just share my tablet. By the way, I have a new wallpaper. It's here. Okay, so let me just move this back here. And so what's lambda? But I'm just gonna do this simply. Done. Lambda functions, also known as anonymous functions, are small unnamed functions defined with the lambda keyword. Lambda functions, small unnamed functions. Okay. Functions. Oh, sorry, let me. Is there a way to share my tablet as well? Maybe have a screen here with a tablet in the bottom here or here in the top. I'm gonna take a look at this. But okay, so I know what a lambda function is. So I think I have a built-in function for lambda, yeah. So what this does is it creates a built-in for a lambda function, and we are taking as input our environment. We are taking as input actually a list of symbols and a list that represents the code. And afterwards, we should return a lambda function. So just to make sure what happens here. Okay, these are assertions. I don't care about this. So follows the same format as our other built-ins. We have some error checking at the top. And then, what are we doing? Okay, so we have the error checking at the top. We are checking that, we're making sure that the Lisp value A has two elements. This is the name of the function that will be printed out once we print out the error message itself. Then we assert that the first one is a Q expression, that the second one is Q. The second one is a Q expression as well. Then for every element here, no, for every element in the first cell. But what is the first cell? What is the first cell? Formals. These are the arguments. Okay. So these are the arguments, I assume. These are the arguments. Are these the arguments? Are these the arguments? Let me come back here. Can I share this on another screen somehow to make it a separate screen? Okay. These should be the arguments. I believe. I believe these are the formals that are mentioned here in the code. So if these are the formals, and they should be, we are talking about them here. So we have the formals, we are popping them out of the Lisp value. Then we have the body, we delete the clear, the initial element, the initial structure from the memory, and then we create a new lambda function. Okay, just a second. Yeah, I always come unprepared. How the hell do I do this? Yeah, like this, and I do like this, and this I do like this. This goes here. So now, sorry, I'm just checking. I'm just thinking of the way to. Okay, I can do this like this. Okay, just a moment, please. Okay, so, and then we have written the method here for creating of our lambda function. We have our new and improved assertion methods here. Everything is okay. So we already done this, so I don't think there's any need to devolve into this any further. How can I strike through? How can I strike through this link? I know this is a link. What else do I have? Importing and exporting nodes. I don't need this. Synchronizing. I don't need this. Tips. Maybe the tips can be useful. This is great. We can also write math, but I don't care about the math. I want this. How to first let me read through this. This code defines a function called built-in lambda, which appears to be part of a Lisp-like code language interpreter written in C. The purpose of this function is to create a lambda in the language being implemented. This is the return type of the function, which seems to be a pointer to a LO structure, likely representing a value in this Lisp-like language. We have the environment, or the context in which variables or functions are stored. Are we even using the environment here? Do I see E everywhere? No. Then why am I providing it here? Okay. Something to ask yourself here in the future. We have some assertions. We have some. Can I hide the? Yeah, to have more space here. We have the assertions here, and these lines perform check. Okay, to ensure that the lambda function has been giving the correct arguments. Now, here is the parameter check loop, and then creating the lambda function. Let's remove the first item on the list and returns the first item and the second item extracted from A. Okay. How can I strike through and in Markdown? Double tildes. Double tildes. Is this the tilde? This works. I keep pressing Control C. So I have this. Now let's talk about the parent environment. What happens is that we are giving. Can I do this? Test. How hard is it? No, I don't. It's too much. It's too much. Yeah, the same way as I learned Vim, I'm also learning Joplin as I work, as I go through it. Okay, I don't care about this. So here. Just a second. Functions. Where's my tablet here? It's here. So we are here. What happened is that we have given functions their own environment. And in this environment, we will place the values that their formal arguments are set to. This will be a function environment, and here we will have most probably values and so on and so on. I don't know why I wrote all three of the variables as a 7. So once we want to evaluate the body of the function, we can do this in this environment and know that these variables will have the correct values. But at the same time, we want these functions to be able to access variables which are in the global environment, such as our built-in functions. Oh, okay, interesting. So not only we have function environments, we should relate the function environment to the big app environment, which apart from the variables also has definitions for methods such as add, tail, plus, minus, stuff like that. So the function environment should be able to reference the global environment. So how can we fix this? We can solve this problem by changing the definition of our environment to contain a reference to some parent environment. Just a second. And as I said, only a moment has passed. Then when we want to evaluate a function, we can set this parent environment to our global environment, which has all, we can set this parent environment to our global environment, which has all of our built-ins defined within. So what does this mean? What does this mean? changing the definition of our environment. But what's our environment? To contain a reference to some parent environment. So is this our environment? This is our environment. So we can, so it will contain a reference to a parent environment. But when we want to evaluate a function, our parent environment, this environment, this environment will be part of this environment. This function environment will be part of the app environment. Okay, so here it says in the book, the way the parent environment works is simple. If someone calls, where is the method? If someone calls this method on the environment and the symbol cannot be found, it will look in any parent environment to see if the name value exists there. So it will go. I think JavaScript is doing something similar to, again, I'm doing a really bad act of blasphemy. I'm comparing JavaScript to C, but JavaScript is doing something similar when it comes to the context where the variable is found. So if it's not found in a local context, it can be found in a in the one encompassing this, and all the way upwards until we hit the global context. So if we call this and we cannot find the symbol, we will look in the parent environments and we will go all the way up until the variable is found or there are no more parent environments. So let me just look again, because once we started working on functions, I kind of got lost, not gonna lie. So I'm iterating through the environment. If there is a symbol here that's equal to a symbol in the environment, I'm copying the value inside here. Otherwise, I couldn't find the symbol. So where are you? Where are you, my friend? You are here. So this is the environment structure. Again, we have the count of elements, we have the symbols, we have the list of values. So what do I want? I want to. So if I have just do this a bit better. If I have an integer of count, and if I have the names of the functions, and if I have the values, I need another structure. Oh man, this brace is ridiculous. So I need another structure, and this other structure will be the list of parents, right? So where are you? You are here. You are here. Pair. So the book calls this variable par. Why? What's wrong with C developers? Why don't you just call it parent? Or or symbols or vowels. It's like symbols. It's like only 3 extra characters there. Oops. So where am I creating? I think I'm creating somewhere a new here. I'm creating a new lambda functional list value. I'm allocating some memory. I'm setting the type. So what should I set for the par? Is it null? It's null. What? No, it's not here. It's not this method. Oh, I almost. It's len new. Where is it? Ah, it's here. So it should be e par is equal to null, and this should work. This should be okay. So now, because we are searching for values inside our environment, get just keep in mind I have undiagnosed ADHD. I think I have at least. So my tablet is shutting off every couple of minutes because it has most probably a sleeping time. So let me just do an Android tablet. How to stop sleeping time and for a couple of hours. Yeah, I want to temporarily adjust the sleep settings. Display settings, sleep or screen timeout. Let me test this. Display screen timeout. Where are the 2 minutes? 2 minutes, 2 minutes. Keep the screen on while you're looking at it using the front camera to detect your face. No, think I'm gonna increase it to 5 minutes. I think 5 minutes is enough. If I'm not using it 5 minutes, then I'm doing something else. Okay, let's go back to coding. Yeah, so I want to get a value from the environment. So how can we now add search of the parent environment here? Okay, the thing is I have no idea. I haven't looked at the solution in the book, so I'm gonna try to I'm not guessing it. I'm just trying to understand it from an intuitive model. Heuristically. I keep mispronouncing words. So I think this is okay, but I need another one. So I need an if block, right? If there's a par, I'm gonna call len of get on this par, and I'm providing the same k here. It is wow. Ha! I'm so proud. I'm so proud because of the fact that when I started this, I couldn't tell my head from my ass when it comes to C, and now I think I could at least I can handle myself in it. You know, I'm far from an expert, but I can work in it. If someone tells me, "Hey, write hot fuzz in hot fizz," what's the name? Oh god. I'm mispronouncing the words. Return error. Wait. So I don't need this. I need to. So I need here. Paste. Symbol not found because we don't have the symbol. Otherwise, come here and return this. Nice. This still doesn't work because we need a copy method. Where's this method? So it's here. I mean, I'm using it, but I haven't declared it anywhere, so I need to declare it. Where's the next instance here? Okay, so now the next one, I just took a quick glance and it's a fairly complex one. Copy. So what I'm gonna do, I'm not looking at the code. I'm trying to understand how it goes. So let me move here. So this is the clem copy method. So what should this method do? I need to copy. So I need to, most probably, I need to allocate some memory. What then? Let me just see. What's the structure of ln? Where's here? So allocate memory. Copy count. I think I can copy count easy because it's just a simple number. So how can I need to iterate through sims. So I need to iterate through sims. I don't think this anymore. So I need to iterate through sims, right? Yes, but how? Do I need to allocate some memory? Allocate with the question mark, I most probably need, and iterate through files. Files. Let's do this. Why am I? Where is it? It's here. So I'm creating. Okay. Why am I? Why can't I go? What? Okay, I'm creating a new environment. I'm gonna call it new. I'm allocating. What am I allocating? The size of what? What am I? Sorry. Preferences. I really like this theme, but this is so bad. Colors. Is this the color? Or is this the color? What if I do this? Oops. So it's not this color. Is it this? I don't think it's this either. Or maybe it is. But I'm gonna fuck something up. No, 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 it's... Ah, wait. It's this one. Show bold text in bright colors. Why? Colors. It's one of these guys. Right? No, it's the green ones. Oh, it bugged out. And what happened here? Nothing happened. Okay, let me go back to white. And that's it. I hate this. But all of them are... Oh, this one. This one is hard to look at. Galaxy. Okay, this can work. So it's Galaxy. I just need to put it as my default theme. How? Layouts, profiles. I know how. I go here. I go layouts. Instead of Mirage, I'm gonna use Galaxy. Window. Default. New layout. Galaxy. So now, let me just close this and try this again. Close. Oops, let's close both of these. Close. Terminator. It's the Galaxy, and if I split it... Oh! Why? References. Galaxy. It should be Galaxy. Default. Oops. I broke it. Close. Just a second. In Terminator, how to have the new split window have the same theme as the existing one. Preferences, profile settings. Preferences, profiles. So I'm going to Galaxy, where are you? It's here. And now I can't right click. It says here, make sure right clicking on the profile set as default, but I can't right click, man. Profile, wait. Yeah, this is the profile. There's a problem. I can't seem to right click. I don't want to edit anything, man. I don't want to edit this, man. Why can't I? Can I move it? No. Can I add a new? Can I add a? No, I don't want. Why is the right click not working? How to set a theme as default terminator? Go to preferences, choose the layout tab. Are you fucking kidding me? I don't care about this. Okay, no idea, no idea, no idea, no idea, no idea, no idea. How is this possible? How can I do this? Why now have this theme? Terminator. What? References, layouts. It should be a galaxy theme. Why? It's gonna freeze again, right? Let me remove this. Let me remove this. Here I'm gonna use default layout, profiles, galaxy, but it looks bad. Is this even the galaxy theme? Why does it look like this? Where are the colors here? These are the colors. Profiles. Aurora. No, I don't like this one. Dark pastel. I don't like this one. A slider. Banana blueberry. Ugly. Galaxy. Especially ugly. Okay. And Mona Lisa. No, man. Oh, Mona Lisa is so boring. Relaxed. This isn't relaxed at all. Too strong. Too dark. Too small. Too dark and small. Too dark and small. I don't know. Argonaut. Dark pastel deep Dracula. Oh. Oh, this looks whimsical. Oh no, it doesn't look whimsical. It looks ugly. Flatland. Why can't I change? Flatland. Ooh. Flatland. So what now if I do this? I like this. I like flatlines. So let me just set this. Let me just set this and we'll be on our way. So it's gonna be flatland, close. There's another one. It's flatland. I like this. Chapter 12. Let's continue. Length. It's gonna be length. Copy. Where are you? Here. Okay. At least this looks somewhat nice. So what should I add here? It's gonna be the size of the list environment. So we created an empty. My tablet turned off here because I spent so much time trying to set up my environment. So I'm here. Why are the colors moved here? Actually, I like them on the right. So let's keep them on the right. So what should I do now? Ah, so here, okay. So I need to copy the sims. So it's gonna be sims, but I need a real copy. So I'm gonna need to allocate. How will I allocate this? How will I allocate this? So it's malloc. It's a size of, what is the size of a character? A reference to a character. Ah, times the count. I'm right. I don't believe this. So it's gonna be like this. Character times count. Same thing for the values, most probably. Size of Lisp value times count. Now the parent will be okay. Now I understand now why the book said that we're just gonna copy the parent. It's not, it's just a reference to the parent element. What is the difference between these two lines of code? I know that the vals variable will be filled later. But what, how do these two properties behave differently? Let's analyze the two lines of code to understand the difference in the behaviors and purpose. So this line dynamically allocates memory for an array of pointers to LL. It reserves enough memory to hold this many elements of this type. This means that this will point to a contiguous block of memory that can store a specified number of pointers. Now, because you are using malloc, this memory is allocated on the heap and you must manually free it later to avoid memory leaks. After this line, the values inside the allocate memory is allocated, but this points to the same memory location as this one. So it points to the same memory location. A part. It does not allocate new memory, but instead creates a direct reference or pointer copy. They will point to the same object or value. There's no need to free this pointer separately, so it's just a reference to the same memory that environment parent points to. You should only free it if you allocate the memory yourself and manage its life cycle. Great. Why? What's the name of this guy? It's Flatland. Why have I opened another one of these? No idea. So, this is okay. I can also copy the count because it's a simple value. Now, I'm iterating through this. I'm iterating through this. I'm iterating through this. So, okay, now I'm going back to the book. So I'm allocating memory for this individual element. String copy, then I'm just copying it. Simpson I is Simpson I. Then the same thing, but I'm just doing it for the values. I'm using LL copy. This should be all right. And then I'm returning again, saving it, and now this doesn't work. LL copy. So this is the problem. 259. I need to do this. I need to save it. Will this work? No, because Ellen copy is missing completely. Len copy. Where's the next instance? It's here. I'm just gonna copy the whole thing, and I'm gonna paste it here. I'm gonna paste it here. Save. I think it's gonna work now. And count is used uninitialized. 631. Where is count? 631, 632. Ah, almost. I almost made a mistake. Can I paste it here? Yes. I can delete this. Save. And now, ladies and gentlemen, we compiled the functions script file. So we are not done yet, because now by having parent elements, we should change how we define the variable. Now, there are two ways of defining variables now. How to define a variable Now we can either define it in the locally or globally. We leave the len put method the same. It can be used for definition in the local environment, but we will add a new function len def for definition in the global environment. This works by simply following the parent chain up before using L, and we put to define it locally. Okay, do we have this method? Most probably not. Def, I missed it. Len def, we don't have it, so we'll most probably put. Where is the put? It's here. Okay, I'm gonna add it here. I'm gonna add it actually below this because it's gonna reference this method. So it's gonna be void def. So what am I defining? An environment, the key, the value, and I'm going to do while e has a parent, move while e has a parent, move e is e par, and then once it doesn't have a parent, we're gonna do this. No. So what are we doing now? This distinction may seem useless. But we'll use this to write partial results of calculation to local variables. And we need to adapt our built-in def functions and reuse the common code. Let's set it here. Def length add built-in e equals is gonna be built-in put. I haven't myself yet understood this. Where do I have this? Built-in methods. Built add. Where's the next one? It's here. So I'm just gonna add them here. Lval built-in def e lval a. So I'm gonna return built-in var ea def. Same thing here. Built-in put. What are we taking? We are taking this. We are taking this. Okay. Return built-in var ea equals. And I think we need to define the built-in var method now, right? I think I do need. Yes, I don't have it. Oh wait, I have it. The definition of built-in def. Where do I have built-in def? Built-in def. Oh, I have it already, right? Built-in def. What? Oh wait, what's happening here now? Okay, so we will rewrite this to be built-in var. Okay, save it. I hope it won't break now. I don't think it will. It will. It's breaking now. What the hell is it breaking? Implicit declaration. Did you mean built-in evals? Okay, I need to declare it most probably at the top. 55. So here it's actually 89. Paste. Remove this. Remove this. Save it now. I think no, it isn't working. Too many arguments to function built-in var. Built-in var. Where is the next definition of built-in? It's here. So what is the built-in var taking? It's taking the this, and function, right? Save. Now the forward declaration is gonna throw something. Built-in def. Too many arguments to function built-in var. Yeah, 289. Where are you? 89 is gonna be here also a character. It's gonna be a character pointer to a function. Save this. It works. Okay, now oops. Now. I think I'm gonna call it quits here. We are gonna continue with this method in the next episode. And so let me just write this. Function calling parent environment, so it's here. Continue with the built-in var method. Oops. And that's it. Thank you for watching.